Today we're looking at 10.7 special segments and circles. So there are going to be three theorems today. I'm not going to write out the whole theorem for most of these or any of these. I'm going to use a diagram and basically just what the theorem says. Hoping that simplifies things. If you need the actual theorem, you can find it in the book for the section chapter 10.7. Right. So the first theorem that we have is theorem 10.15. If we have two chords drawn in a circle, then we can make a comparison of the lengths that are formed by the chord segments. So the chord segment AB, BC, BD, and BE. And what that looks like is simply product of one pair of the chord segments is equal to the product of the other. Now, it is from the same chord, so it's AB times BC and DB times BE, and that gives us the first one here. The second theorem talks about segments that are secants and their segments. All right. Now, this one is not a product of the two parts, not the way that it was on the last one. It's going to be the product of the outside segment times the whole segment. So we get AB times AC. So AB times AC, the whole segment, is equal to the exact same thing happening on the other side, which is AD, that's the exterior segment part, times the whole AE. And our last, maybe not our last theorem, one of our last theorems of the chapter though. Same kind of thing, but if one of the two segments is a tangent and the other is a secant. So this one's very, very similar to 10.16. The problem is that we have a tangent segment on this one, and obviously we can't take some kind of product from the tangent. So that one just ends up being a product with itself or squaring itself. So we get the tangent segment squared equal to the exact same way that we were doing 10.16, which is the outside part times the whole. All right. Sorry, we'll give you a second here. Just one more time. It's the tangent segment AD squared is equal to AB times the whole AC. All right, last one we're going to look at then. So this is not a new theorem. But it kind of fits with these. What if we had two tangent segments, AB and AC, right? What would need to be true about them? Well, hopefully you remember back, and what's true about them is that AB is equal to AC, right? That AB and AC must be congruent or something like that, right? Good. All right, we're going to look at just a couple of examples today. If we had a circle with two chords drawn in, eight, 4, 4, and I guess I made it a little bit too close here. That's going to be X. So 8, 4, 4, and X. So what theorem 1015 tells us is that 4 times 4, 4 times 4 is 8 times 8 times X. 16 equals 8X. And X is 2. Right. So we have another one with X plus 3, X plus 4, X plus 9, and X. And what I'm going to suggest is that you pause and solve on your own for this one first. Don't get scared about X squareds. Just try to do the problem. Hopefully we remember how to distribute and FOIL. I guess I really don't like calling it that, but I think we've talked about that in class. All right, so hopefully you pause the video and you're coming back now. We have X times X plus 9 is X plus 3 times X plus 4. Distribute, we get X squared plus 9X is X squared plus, we get 4X plus 3X is 7X and plus 12. We subtract X squared from both sides. The X squareds cancel out. Subtract 7X. We get 2X is 12. Divide by 2 and X is 6. If we had two secant segments, kind of like this. Okay. Remember that we're taking the outside part and multiplying it by the whole. It's not the outside times the inside. So the segment here is 5 plus X. And the segment here is 12. So we get 5 times 5 plus X equals 7.5 times the whole, which is 12. 5 plus 5x is 7.5 times 12. 84 and 90 is 90 minus 25 from both sides. 65. Divide both sides by 5. X is 13. All right, and then our last one. Last one, we had a tangent and a secant. So for this one, we take the tangent and square it. We get 36 equals 4 times, don't get confused here, it is not times x, right? It is times 4 plus x. So we get 36 equals 16 plus 4x. That is 20 equals 4x. And x equals 5. And that is all that we have for today. So your homework is going to be on page 754. There's numbers 6 to 13. And that should be done by 8 p.m. tonight.